An introduction to GeoGebra. In this introduction, I'm going to use the idea of an orthocenter, a specific item related to triangles, to construct some perpendicular lines, and demonstrate the difference between an intelligent diagram and a less than intelligent diagram. Well, I actually won't contrast it. I'll just build one. Underneath each one of these icons, there are multiple tools that are related to the initial one. This polygon or a regular polygon I can specify. If we roll back over to the segment tool, the default is a line tool. But here I'm going to use the segment tool, and I'm going to build or construct a triangle just with 3 segments. The software intelligently connects the segments to each vertex as I construct it, if I direct it to do so. Let's go ahead and construct a triangle with the polygon tool. You can see that it'll give me one specific advantage that I won't use in this exercise, but it defines the region. And over here on the left under dependent objects, it gives you the length of each of the sides, and also gives you the area of the polygon, and it gives you the coordinates for each of the vertices. Let's go next to measure the angle. Measure each of the 3 angles, interior angles of the triangle, and in doing so I'm going to select point C, A, and B in a clockwise fashion, and you'll see the angle label alpha underneath A. And now I will select A, then C, then B in a counterclockwise fashion, and notice how it does the reflexive angle. So typically I'm going to have to continue to select the angles B, C, A for instance in a clockwise fashion to ensure that I'm getting the interior angle, or at least the angle that I desire to measure. Let's finish it off. Do A, B, and C again clockwise, and there are the 3 interior measures. Next I'm going to actually select the perpendicular line tool, and in GeoGebra you actually select the task that you want to complete, and then go ahead and select the parts. As you can see, as I hover over it, says select point and perpendicular line, and those 2 ideas will constrain my perpendicular line. I construct it by selecting a point and the point that the perpendicular line will go through, and the line which it is perpendicular to. For some that might be hard to see. Let me drag vertex A, and you'll see that it is in fact perpendicular to that opposite side. We refer to that as an altitude. An altitude goes through a vertex and intersects the opposite side at a 90-degree angle. Altitude from C to side C, or segment AB, and then the last altitude from A to segment BC. Notice the point of concurrency where the 3 altitudes intersect. That intersection and that point of concurrency is referred to as the orthocenter of the triangle. The orthocenter of the triangle is going to be interior, or reside in the interior region of the triangle, except when there is an obtuse angle. Such as there and there. Back to interior. And notice on the left, all the numbers changing as things are moved around. The numbers change live or dynamically. Also notice that the altitudes remain altitudes because I've constrained them as such. In Geometry Sketchpad speak, there are parent and children items. In GeoGebra speak, on the left you'll see free objects. Those are the 3 points that originated the triangle, and then dependent objects, dependent on the free objects and on other constraints. The orthocenter has one other situation where it is not in the interior, and that's when you're talking about a right triangle, or you have a right triangle, and the orthocenter actually lies at the vertex of the right angle. And that's it.